Alright, we're going to wrap up our measurement unit today. And with this one, we're going to be using some addition and subtraction things here just to kind of wrap up how to add and subtract some different measurement lengths. You may have done things like this before, but again, we're just going to kind of wrap up and review these things. And then we are also going to discuss just a little bit with time and temperature, since they are also kind of in a measurement piece. So when you have things like these two examples. So the first one we have 2 feet 4 inches plus 3 feet 7 inches. Really we're adding each piece individually, and we're going to carry over later if we need to. So for instance, we have 4 inches and 7 inches gives us 11 inches. 2 feet plus 3 feet gives us 5 feet. So it's as simple as that. We add each of them individually and then kind of keep it there at the end. Now, for instance, let's say I change this to 2 feet 6 inches. When I added this, if it would be 6 plus 7, that would give me 13. Well, 13 inches is more than a foot. So what we would do is we would write this as 1 inch left over and add a full foot over here. So if that were the problem, copy down the other problem. Copy the other problem down as the original. But for instance, if it would make it so that you have more inches than is in 1 foot, you'd want to carry over. Now the other example over here, 7 feet 4 inches minus 5 feet 9 inches. The thing that's different here is when you go to subtract, you cannot take 4 minus 9. So we can't have that happen. So we cross this out and make it 6 feet. But we don't add 1. We don't make it 5 because that still wouldn't help us. 1 foot turns into 12 inches. So we're going to make this, we're going to add 12 to this and get 16 inches minus 9, which then gives us 7 inches left over. Then 6 minus 5 gives us 1 foot. So our answer is 1 foot 7 inches. And now remember, that's not 1.7 because this is base 12. This is out of a different system. So you can't put 1.7, it's just 1 foot 7 inches. So I'm going to go ahead and give you guys a couple of examples, or just 2 of those to try on your own, just to give yourselves the confidence that you're doing it well, give you an answer, and then we'll move on to some other things. So let's take 1 yard, we'll do 1 yard, 2 feet 6 inches, plus 2 yards, 2 feet and 7 inches. And then we'll do a subtraction problem. So let's take 17 feet 2 inches minus 13 feet 8 inches. So go ahead and complete those 2. So notice here we have a couple of transitions we had to make. So 13 inches, we have 1 inch left over, which makes this 5. However, 5 feet, there's a yard in there. So I'm going to take this and we have 2 feet left over. So we have 4 yards, 2 feet, and 1 inch. So that should be your final answer there. Over here when we borrow, becomes 14, so 14 minus 8 gives us 6 inches, and then 3 feet left over here, so 3.5 feet is how that one ends up. Alright, now we can do this same idea with the metric system. However, for that one, we're just going to, the conversions there are a little different, and we do it all ahead of time. So when we have something like 13 kilometers minus 756 meters. So if I have something like this, before you do anything with the metric system, you want to make sure that they're all in the same unit. So it's easier to go bigger to smaller. So if I rewrote this as 13,000 meters minus 756 meters, that's what I'm going to want to do here. So now we can do this vertically. Minus 756, we're going to have to borrow. So we have 4, 4, 2, 12. Now, this is in meters. You can rewrite that and say that's 12.244 kilometers. If they don't specify, you can write it either way, 12,244 meters or 12.244 kilometers. This is probably preferable because it's a little easier to write this and to say 12.244 kilometers than to say you have 12,244 meters. But again, that's a preference thing, and if they don't specify, then you're welcome to write it however you wish. I do want to take a minute and talk about time and temperature. Now, time is very similar to what I just mentioned with measurement, because when you're looking at time and you're adding or subtracting it to find elapsed time, this is where you're going to convert it to minutes and hours instead of, the things that we just looked at. Instead of feet and yards, you're looking at minutes and hours. So for instance, if you say you started at 6:03, and we passed 1 hour 47 minutes. What time has it been? Well, you can just simply add this. We can just say 6:03 plus 147, and we end up with, it's now 750. So that's a way to do it. You can just straight add these. Now, if you say we ended, so we can call this example A. If we say that we ended at a certain time, so let's say it ended at 7:47, and it had been 2 hours 13 minutes. We can go back and subtract that as well. Now there might be times where you have to borrow. Now this is not going to be one of those times. So when we subtract this, we end up with 34. So it was 5:34 when we started. Now let's say, for instance, I told you that this had been 2 hours and 50 minutes. So instead we were subtracting this. When I subtract, we end up with 47 can't come out of 50. So what we do is we say, okay, well this is now going to be 6, and we add 60 minutes to this. So now it turns into 107. Subtracting 50, we end up with 57 minutes. So it would have been 4:57 at the start instead. And so that's how that difference occurs. And then with time, just a couple of the differences you want to be aware of. I'm not going to do any examples or anything with this, or excuse me, not with time, with temperature. When you're talking about temperature, we mostly deal with the Fahrenheit scale. So for instance, water freezes at 32 degrees Fahrenheit. However, that's a little different because on the Celsius scale, that's going to be at 0 degrees. But it's not just a straight, you don't just add 32 to it. It's not quite that different. When you're looking at Fahrenheit versus Celsius, there is a formula. We're not going to get into using that formula. You just want to be aware of what it looks like. So we know that water boils at 100 degrees Celsius. However, it boils at about 215 or 220 degrees Fahrenheit. So you'll see that it grows with Fahrenheit much more rapidly than it does with Celsius. So room temperature for Celsius is at about 20 degrees versus about 70 degrees for Fahrenheit. The human body, typically for Fahrenheit, is about 98.6. For Celsius, it's just under 40 degrees. It's right around 38 degrees. So those are just a couple of the differences that you want to be aware of in terms of how Fahrenheit compares to Celsius. So you just know that Celsius is typically a whole lot lower of a number than Fahrenheit is. And there is a formula that we can use to compare those two. We're just not going to look into it yet. But we will probably next year in pre-algebra. Alright, so that finishes out this unit, and we will be moving on to a new unit next time.